Americans believe they have seen a UFO. How many of you in the audience have seen a UFO at one time? Okay, we're not going to take names. I just care. Oh, good, okay. Here's the shocking one. This blew me away when I first read into it. Somewhere between 1 and 3%, various polls agree, somewhere between 1 and 3% of Americans claim that they have had an abduction experience. That's over 5 million people, or in that neighborhood. Not a few thousand deranged people, not a few, disaffected. This is, we'll talk a little more about this. This is a very, very disturbing phenomenon in the counseling profession. Now, part of the problem of the UFOs is they have some paradoxical behavior. On the one hand, they're seen by multiple competent witnesses. They are plotted on radar, sometimes multiple radars simultaneously. They leave tangible traces on the ground, sometimes radiation, evidence of burning, and other things. So they are apparently real in the sense of being physical, on the one hand. There are photographs. Sometimes they show up on photographs, sometimes they don't. But here's the problem. While they seem to be tangible on the one hand, they exhibit behavior that can't possibly be physical. They can go in excess of 6,000 miles per hour without sonic boom. So what on earth does that mean? I'd like to know how they do that trick. They've been plotted making right-angle turns at over 16,000 miles an hour. That defies the laws of physics. That's now perhaps the most disturbing thing of all. They appear to have the ability to materialize and dematerialize without a trace. One of the great mysteries of the UFOs isn't seeing them, is trying to figure out where are they when you don't see them. Some people say, well, they're from another galaxy. Most physicists will debunk that for lots of reasons. They seem to pose that way, but for lots of, if they came, if there are that many coming from another galaxy, you'd think you'd sense the traffic. We'll come to some more reasonable explanations, and you're going to discover the two top researchers in the last century, really, is Jacques Vallée, France, and J. Allen Hynek, the American. Now, J. Allen Hynek was head of astronomy at Cornell, and he set out to debunk this nonsense about UFOs, and he became one of the most ardent, competent, balanced researchers in the trade. J. Allen Hynek, he died a few years ago. Those of you that saw the movie Close Encounters of the Third Kind, whether you realize or not, saw J. Allen Hynek because he was in the crowd. I was on the board in those days with Alan Adler from Columbia, and they had him as just a gesture appear in some of the scenes, just as an extra. And the lacune of that piece of fiction, of course, was patterned after Jacques Vallée, the Frenchman. Both of these respected researchers came to the conclusion that they're not intergalactic. For lots of physics, there are a lot of physics rebuttals to that conjecture. They both argued that these things are demonic. Their term. They've written many, many books. You can check them out. These are not religious people. They're not people with any kind of personal agenda. But they came to the conclusion that these things, on the one hand, and by the way, we take for granted that we strip away the nonsense and the hoaxes, set that aside. There's tens of thousands of files you have to wallow through. When you cut through all that, there's still a core group, a substantial core group of real events that need explanation. And so on the one hand, they exhibit physical properties on the one hand. On the other hand, they also violate all physical laws. And so the conclusion that both J. Allen Hynek and Jacques Vallée and others have come to is that they're hyperdimensional, that somehow they come from another dimension periodically. That causes us now to stand back a little bit and do a little tutorial on hyperspaces. And we're going to get into why we feel that the Bible is an authenticated message of extraterrestrial origin in the first place. So let's talk a little about hyperspaces. There are only two kinds of... A hyperspace, by the way, just a term for a space of more than 3 dimensions. You and I are familiar with two-dimensional space. It's called a scratch pad or a photograph or a piece of paper is a two-dimensional representation of something, typically. Three-dimensional space we're familiar with because we live in it, and we also build models in 3 dimensions. We probably have a vague feeling of a fourth dimension called time. We don't get too comfortable with that unless you've done some special study, but we sort of acknowledge that reluctantly. Hyperspaces, frankly, is just the term used to study spaces of more than 3 dimensions. And we discover there's only 2 kinds of people that can really relate to hyperspaces. And that's mathematicians with special training and small children. Okay? Because they haven't, their prejudice has been blindfolded, so to speak. Now, the one book that is second to the Bible in its publication, all of us know the Bible is the most popular book in the history of man, but the second to that would be Euclid. And that's where most of us have been taught in school. And most of us, when we went to school, had trigonometry or plane geometry, same subject in a sense. We all know that a triangle, if you add up the angles of a triangle, adds up to how much? Anyone? 180 degrees, you betcha. So if I have a 30, 60, 90, it adds up 180. If I have a 45, 45, 90, in fact, any triangle, if I add up the angles, it would add up to 180. Suppose, though, that my partner and I went out to a large field here, and we very carefully laid out with the transit a very large triangle, and when we got back with our figures, we added up the 3 angles, and it added up to more than 180 degrees. What would you conclude? That we'd messed up, huh? No, what have we encountered? Anyone? The curvature of the earth, exactly. See, if you take a course in navigation, one of the things that you'll have to get some background in is spherical trigonometry, where you can have a triangle with 90 degrees in each corner. And so, see, this little rule that we all learned, that a triangle, by implication, a plane triangle, a flat plane, adds up to 180 degrees, that's only true for a universe of 2 dimensions. So when you find that rule violated, it's a hint that you've encountered an additional dimension. And Dr. Einstein made history with that insight, because he was grappling, of course, with the nature of space, and he realized that length, mass, velocity, and time are relative to the velocity of an observer. In 1915, he generalized that, basically discovered that there's no distinction between time and space. And perhaps the most important thing from the general theory of relativity, we won't get in the math, of course, but is to realize that time itself is a physical property. You and I do not live in 3 dimensions. We live in at least 4. In fact, we now discover much more than that. But this idea that Einstein recognized as he grappled with the properties of space, that there's an additional dimension required, and he went to 4 dimensions to resolve the time issue. And his theory of relativity has been confirmed over 12 different methods to over 14 decimals. So it's no longer really a theory. It's well-accepted basis in certain fields of science. So when we need to go beyond Euclid, which of course deals just with 3 dimensions. And in June 10th of 1854, the most important lecture in mathematics was given by George Riemann. He invented a thing called metric tensors. And that tool that he developed proves to be one of the most profound tools in advanced physics. And it took over 50 years, in fact over 60 years, for Dr. Einstein to use that tool to develop his 4-dimensional space-time. And it's too bad that Einstein went to his death frustrated by not being able to solve certain problems, which if he had applied the technique going to 5 or more dimensions, they would have yielded. It took his successors to do that. Because in 1953, Kaluza and Klein both developed more than 4-dimensional models which integrated light and supergravity in a model. In 1963, 10 years later, Yang and Mills both developed what they call Yang-Mills fields, which reconcile electromagnetic and nuclear forces. That physicists are pursuing some way to integrate all that we know about the physical universe into a common model. And as early as 1984, and it's still a current conjecture because there's still problems with it, but scientists now generally believe that you and I live not in 3 or 4 or 5, but in 10 dimensions. And if you read in this area, you'll encounter superstrings and such, and we have briefing packs on this for those that want to get into it more. The point being, we need to understand that the 3 dimensions you and I are familiar with are not all there is. There's more. Let's